Yes, good afternoon, everyone. I, Richa Sharma, on behalf of ICT4SD conference, I welcome you and I welcome both our session chair in this conference. Welcome to the technical session 3B of 5th International Conference on ICT4SD. Due to pandemic COVID-19, we all are going through a new normal phase. And the team of ICT4SD wishes you a safe and healthy time for you and your well-wishers. We are constantly trying to overcome the challenges that research community is facing at different level. We are we are at Global Knowledge Research Foundation are fully committed to the contribute and enhance the digital experience in the research activities. To continue further, this conference has received tremendous number of submission, which has across more than 1,000 plus numbers. And 20 plus countries has been marked through direct submission and special sessions, out of which 340 papers were accepted by the technical review committee, and we were only able to accommodate 160 paper in a 2 volume for this year ICT4SD publication. Once again, we would like to congratulate you for your session, for your research work, and to be a part of this successful story in a fifth version of this conference. Now, I would like to welcome to take our session chair. One is Dr. Swati Nikam and Dr. Meenakshi S. Arya. Dr. Swati Nikam, she is an assistant professor in the Department of Computer Engineering, Dr. D.Y. Patil Institute of Engineering and Technology. Almost, she has 18 years of experience, also has the experience of organizing 2 workshops. Am I audible?
Yes, you are audible. Go ahead.
And our another session chair is Dr. Meenakshi S. Arya. She's a professor in Department of Computer Science and Engineering, Vadapalani campus, SRM Institute of Science and Technology. And also she has a 5 years of teaching experience and teaching experience. And her research interest in digital image processing, data analytics, and green computing. So I welcome our both session chair. And now move forward, we invite our first presenter. Before I start, I can mention one thing. There is 8 minutes for presentation and 2 minutes for question answering round. So, Mr. Omar Sharif.
Yes. Can you hear me?
Yes.
Okay.
Please present your presentations.
Can you see my slide?
Yes, please go ahead.
Assalamualaikum. Good afternoon, everyone. I'm Omar Sharif from University of Liberal Arts, Bangladesh, Dhaka, Bangladesh. Thank you to honorable person, and especially thanks to ICT4SD for accepting our research paper. Now we are spending a pandemic situation, and it is a big challenge for us to recover. Our research paper name is Lifesaver Robotica for Accidental or Disaster Place in Emergency Situation, which is an Arduino-based control system. Now I will describe about our research paper in details. In the world, every day lots of incidents are happening, and among them catch fire and disaster are common accidents. And for the reason of this incident, a lot of people are dying every day. The maximum fire death rate is existing in Zimbabwe, which is 6.57 in around 1 million people. In India, 2.2, in Russia, 3.64, and the rest of the others are shown here. These incidents are happening for some reasons. When an accident is happening, the rescue team faces some problems in rescue time. Rescue team risks their own lives for carelessness, resulting in their own death. Due to lack of technology, they cannot provide any immediate solution in rescue team. Firefighters cannot detect the temperature of the burn place, so they lose their lives in the excess temperature, including frostings. Many times, rescue team cannot find everyone from the burnt or disaster area. Rescuers are often unable to identify where people are taking shelter in the place. Sometimes rescuers go to the rescue without any preparation, so it takes a lot of time to finish rescue operation. As a result, it is not possible for them to save everyone. In Bangladesh, the fire death rate is decreasing yearly for taking some steps. Here, we see that in 2008 to 2009, the death fire rate was 1.87 something, in around 1 lakh people. And these death rates are gradually decreasing yearly. In 20 February 2009, the most tragic accident was happened in Champaran Churihatta, and the same year, 28 April, another most tragic incident was happened in Bonani, where the fire broke out in whole area and lots of people was died for fire. In 24 April 2030, a great terrible accident was happened in Shabwa, where a loss of garments factories was existing in the building named Rana Plaza was collapsed and lots of workers was died in that day. In our research paper, we are providing a lot of solutions for facing these terrible situations when the rescue team are doing rescue in the burn and disaster area and help process to get outside. Our concept is to design an Arduino-based rescue car which is controlled by smartphone. The rescue car can be measure temperature, distance, and detect human motion for survive and rescue people from burn and disaster place. Our plan is to rescue people from accidental area and disaster place using robotic car and help firefighters to rescue process safety. We are following some steps to build the rescue, and the steps are to gather information, to gather real network, design a model, implement backend logistics algorithm, and the last one is finalizing the system. There are some important words which is related to our research. The first one is smartphone-based robotic control for surveillance application. M7 from India, which is designed to develop a robotic vehicle using Android application for remote operation attached with wireless camera for monitoring purpose and transmit real-time video with night vision capabilities. Team Maria and others from India who have developed a robotic car which is used for autonomous temperature measurement for early detector of fire in forest, etc. Malia Rahman and others from Bangladesh who are developing multiple motion controlling mechanism of a robotic car using Arduino Uno, which was a slave. The functionality of a rescue car are develop an Android application that uses a robot as a remote control. We develop a robotic rescue car which can help to save people's lives. We develop an Android application for fetches data from particular sensor to show the specific data. Visualize live footage from disaster area and send every footage to rescue. Our system will be easy to use and too much user-friendly. To build our robot, we are using these components like Arduino, transistor, gear motor, some important sensors like motion, temperature, and the rest of these. Here is our block diagram. We see that each component is connected in Arduino and an Arduino device connected by wireless to control the whole system. For programming language, we write our system logical part in C++ language. We use different types of libraries such as PCM.h for speaker, servo.h for servo motor, servo serial.h for Bluetooth module, and many more. We write the whole code in Arduino IDE for smoothly running the rescue car as well as the other component and uploaded by IDE. For Android application, we also develop our Android application using Java language for internet with the robotic car. Here is our rescue car circuit diagram, and we see that each component is connected with Arduino microcontroller, where a power unit is supplied in Arduino to serve the whole system. In our robotic car can survive any disaster place or a burn area. When rescue team are going to rescue people, they will ensure the situation of the burn area by using our rescue car. In burnt area, rescue team will send our rescue car and the rescue car running the whole area, which is controlled by our developing application. Rescue team control the car movement by application, and the rescue car will send the data to particular application. This rescue car captures the temperature and send data to the application. If the rescue car finds any hostage in burnt area, then it gives a detector signal to the application using unity motion sensor. The rescue car also captured the live footage of the burnt area and send footage to rescue them. We are using some predefined voice command to alert the hostage in burnt or disaster area so that all the hostages can find rescue team for getting help. In this way, our rescue car can participate as a pre-rescue system, and rescue team can complete the rescue mission easily and will save a lot of life. Here is our own application. We see that all the sensor data and button for control the system.
Umar, you have
There is
last 2 minutes. Please conclude your presentation.
okay. There is our system, where we check the system individually component to get the perfect accuracy. Our system is also surveying in night mode by using a loss of light. We are doing a user satisfaction survey in around 30 people who are the local firefighters, and we got a good support from them. Our survey depends on some functionalities of our system like measuring temperature, detect motion, and others, and the results are here. In future, we'll improve our robot by implementing GPS technology. We can be lower exact location of a hostess. By using GPS technology, the hostess can be sent signal by his or her exact location in disaster area. For costing purpose, we are using Bluetooth technology, but in future, we'll implementing long-range wireless technology in our receiver. In future, we're planning to install high-definition camera and also thermal scanner in our speaker for visualization and live feeders. There are our research paper references, and we did a lot of study from this reference article. Thank you.
Yeah.
Hello.
Hello.
Yes, sir.
Yeah, Dr. Swati, go ahead.
Yes, congratulations for the presentation. I have one question, like what will be the exceptional conditions where it might not work? Have you tested any exceptional conditions?
I tested in
Extreme.
small disaster area, like just testing purpose. We burn a fire in something somewhere and tested for temperature, for distance, and humidity sensor, motion sensor. But in practically, we are not testing. Uh, our system is also in practice.
Okay. Okay. Fine.
Hi, Omar. My question is just an extension of what Dr. Swati just asked you. I have two questions to you. One, when you say that it is a lifesaver robotic car, so are you going to, is this a system which you are going to embed inside a car, or you intend designing a car on your own? Because what I could see is just a small model of a car. So what kind of a system?
It's just a protocol of our implement system, but in future we are developing a large system, and this is just a model.
All right.
It's just a model, and we use Bluetooth technology, but in future we are using wireless technology. That's for that we can communicate or do a three-straight billing or four-straight billing in future.
Okay. Have you just given a thought of what can be the recommended material for designing this car? Because it has to be fire tolerant. So what material would be required for designing this car?
It should be hard materials, because we are rescuing in fire area or disaster area. We should have to use hard material and strong material.
Okay. Okay. Thank you so much. Thank you. Yeah.
Thank you.
Thank you, Umar.
Thank you.
Now I would like to invite our next presenter, M. Rajesh Khanna.
Yeah. Hello, it is audible to you?
Yes, Rajesh, it is audible. Please go ahead.
Okay. Whether the presentation is visible to you?
Yes, Rajesh, it's visible.
Okay, good afternoon everyone. My name is Rajesh Khanna, and I'm here to present our paper which is titled as Intruder Insinuation and Smart Surveillance. As we all know that many organizations, malls and jewelry shop have CCTV cameras for surveillance, but it is not smart enough for surveillance, because a person either has to monitor it for 24/7, or the cameras are just used for recording purposes. It also consumes lot of memory, and it requires a person for monitoring. In that condition, we are implementing our project, or we are presenting a paper which has some advantages than the regular CCTV cameras. The main advantage is that our cameras will start working when motion is detected. We are using a PIR sensor. So when the motion is detected, then only the camera is turned on. So we are consuming a very less memory for storage purposes. So it is memory efficient. And then we are implementing face recognition and mask recognition to our project. So in this case, the existing system, it is just as a normal CCTV camera. It is just used for monitoring. And in our proposed system, we are adding face recognition and mask recognition to it to improve the surveillance and to avoid any manual work which is done by a person that is monitoring 24/7. So this is our system architecture. We are using Raspberry Pi for it. PIR sensor, buzzer, GSM module, GPS module, camera. It is all connected to it. So it will be a very small kit and compact kit which can be implemented in real time. So this is a block diagram, main Raspberry Pi in which all the sensors and everything is connected. And this is our main working of face and mask detection. For face detection, as everyone know, we have to just collect a person's image for recognition. Likewise, in organization or in malls or in any shop, there can be an authorized person who can access the shop even at closed times. The main aim of our project is to is for surveillance when the shop is closed. So we have to collect some authorized person faces and we have to process it, just like what other face recognition process like. It is like we are gathering the images and we are processing it and we are training the system to identify them to identify that person in real time. That is what it has shown. Phase 1 data gathering, and phase 2 it is used for training the faces so that the system can identify them. And this phase shows that the system identifies the person. So we have a lot of modules, and for face recognition, we are using air cascade algorithm. We have many face recognition algorithm. We have chooses air cascade algorithm because of its efficiency and accuracy. So in air cascade algorithm, it has majorly 4 steps. That is air feature selection. It means consider a face which is get from real-time surveillance camera. There can be a lot of portion which has to be neglected because face has its features like eyes, nose, some features. Only that portion we have to gather. So this is called as air feature selection. This feature selection helps us to identify the features like eyes, nose, and common face features from that frame or image we have got. Then creating integral image. This integral image we are used for calculating the features because a lot of features are there. So the processing has to be fast. So we are using integral images. And third one is with classification is Adabus training. In image, there can be a lot of portion which has to be neglected other than the face. So Adabus is a technique which neglects all the portion except a perfect frame with all the features of a face. So that is with the face recognition, and we have mask detection. So consider this. Every time when a person tries to enter a shop, he or she may cover the face completely to avoid his face to be shown to someone or to avoid caught. So they will wear some mask to cover their faces. At that time, our system will identify the person who is wearing the mask. So when a person is wearing a mask, the system consider him as an illegal entry person or unauthorized person. So the system triggers a warning message to the owner and the nearby police station. So that is how the face and mask detection works. So when an authorized person enters the shop, the system will not do anything except when an illegal entry or an unauthorized person is entered, the system is triggered to send a warning message to the nearby police station and the owner. So here are some examples. So this is motion detection. Like I said earlier, this is more memory efficient. So when a motion is detected only, our camera will tend to capture the video, so it is more memory efficient. And this is authorized face detection. So this person is authorized person, as we have gathered these images and stored it and pre-processed it. So the system finds him as an authorized person, which shows his name. And
Rajesh, you have only 2 minutes. Please conclude your
okay, I will finish it. And this is an unauthorized person. This person is not authorized, so it shows as unauthorized person. And when a person is wearing mask, it concludes him as a thief, and it sends a warning message. So our idea is simple: when an unauthorized person who's wearing mask or an unauthorized person has entered, a warning message has to be triggered to the owner and the nearby police station. So this is the comparison of metrics we have done for various face detection algorithms. In that, most of the times the air cascade algorithm is efficient than other algorithms. So this is the accuracy chart, and there are some examples of what is the accuracy we have got, sensitivity, specificity, and how many data set we have given. So this is the alert message that has been sent to the owner of the shop or organization. And I like to conclude that the normal surveillance cameras can be improved by adding these kind of face detection and mask detection technologies, so that the surveillance becomes easier, and no labor or men required to monitor it 24/7. That's it.
Hello.
Thank you for the opportunity. Hello. Hello.
Yes, Rajesh. Thank you, Rajesh. Swati ma'am and Meenakshi ma'am, please, any comments?
Yeah, Rajesh, I have one question. Now, what can be
Dr.
the
Swati,
percentage?
you have a question, or should I ask?
Yeah, I'm asking. Yeah. Rajesh, can you just elaborate, like, what will be the percentage of false acceptance and false rejection in this case?
In this case, the air cascade algorithms, at most of the time, it gives accurate results. The accuracy of our program of this algorithm is 90%. So most of the time, it is accurate. Sometimes, due to that, when a person is far away from that camera, or the image is not proper, in those cases, there can be some false rejections.
Okay. Okay.
Rajesh, I just had a small question. Today, everybody uses Arduino. What is your motivation for using a Raspberry Pi as a microcontroller for the application?
Ma'am, it is cost efficient, ma'am. And Raspberry Pi is also similar to Arduino, and based on the cost wise, we have chosen Raspberry Pi. It is also similar to Arduino, so there is no difference among them, ma'am.
No, there is a difference. That's why Arduino is more expensive. So, have you done a comparative analysis of why you would go with a Raspberry Pi, which is a slightly obsolete hardware as compared to the Arduino? As
Ma'am,
compared to, yeah.
it is basically the cost. We have decided to build it in a very budget cost and to give the maximum output from it. So we have achieved it with the Raspberry Pi itself. In later stages, we can also use this project based on Arduino, but the budget constraints will be increased. That's all, ma'am.
Okay. Thank you. Thanks.
Thank you, ma'am. Thank you, ma'am.
Thank you, Rajesh. Now I would like to invite our next presenter. It's Anya Trivedi.
Hello, am I audible?
Yes, Anya. Please start your presentation.
I hope you can see my screen.
Yes.
All right. Good evening to everyone present here. Today, I, Anya Trivedi, on behalf of my team from NIT Surat, am here to present our literature survey on the similarity analysis of legal documents. First, we want to discuss what is the need for performing similarity analysis for legal documents. This is based on what is known as the common law judicial system, where one case sets precedents for all future similar cases. What this means is that when a case is presented, its judgment is highly based on the outcome of past similar cases. So there needs to be an efficient way for both judges and lawyers to find similar cases to the one at hand. In this work, we have performed a novel categorization of the work done in analyzing similar legal documents. We categorize this based on citations, based on the content, and based on the summary of the legal document. The first categorization is citation-based similarity measures. This is based on the intuition that similar cases should cite or be cited by the same set of cases. For these similarity measures, it is important to construct what is known as a legal document citation graph. In this graph, the nodes of the graph are legal documents, and a directed edge exists between documents that are cited by each other. So for example, here D1 cites D2. Citation-based similarity measures are based on the fact that there exists a threshold number of what is known as out citations and in citations. Out citations are the citations that a document has. So the out citations for D1, according to the graph, are D2, D3, and D4. In citations are the set of documents which cite a given document. So for D4, the in citations will be D1, D2, and D5. Citation-based similarity measures are in accordance to a citation graph. The first is using Jacquard similarity, where Wag and Anand conducted research in which they made a weighted citation graph, where the weight of the edge was calculated by the Jacquard similarity of the out citations of two documents. This was a very effective way of finding similar documents, as an increased weight showed an increased similarity. Next was bibliographic coupling, which was also based on out citations. Here, two documents were said to be bibliographically coupled if they referred to one or more common works. If this number had increased, was more than a given threshold, then the two documents were similar. Similar to bibliographic coupling was co-citation analysis, which used in citations instead. If a document D cites two documents, then those two documents were said to be co-cited. Finally, a study by Bhattacharya et al., through the use of Node2Vec, calculated what was known as precedent citation similarity, in which similar documents would have a similar set of legal citations. We observed that citation graphs could be used to explore case reachability, which means how many documents were cited or would cite the given document, and case equivalence, which basically showed if two documents were the same. The most persistent limitation of citation-based similarity was the scarcity of legal citation graphs. Also, it was observed that in citation-based methods such as co-citations often underperformed out citation-based methods such as bibliographic citations or graphical embeddings. The second categorization was content-based similarity measures, where the document as a whole and its content were used to analyze whether two documents were similar. The first approach was text-based measures, where the document was represented as a vector in multidimensional space. Then cosine similarity was applied to these vectors to find similar documents. It was observed how a link-based measure would underperform text-based measures due to sparsity of graphs. To overcome this sparsity, paragraph links were introduced. Paragraph links basically linked two paragraphs which had similar content or shared similar citations. Then bibliographic coupling was used on paragraph links instead of out citation to find similar measures. Finally, similar documents would share similar topics. Topics could be extracted using LDA, and if there was a correspondence in the topic sets of two documents, they were shown to be similar. It was observed that paragraph links showed the highest correspondence.
You have only 2 minutes. Please conclude your presentation.
All right. Paragraph links showed the highest correspondent with expert opinion because they were able to capture the nuances in each and every paragraph. Further, it was observed that it would be fruitful to analyze only parts of the document rather than the whole verbose document. This brings us to summary-based similarity measures, where only summaries were used to establish similarity. Before establishing similarity, it was necessary to automatically extract the summary. The first approach would be linguistic feature-based summarization, where concepts of a legal case were dependent on the context of a case. For example, if there was a criminal law case, it would highly differ in the concepts as compared to a civil law case. Here, catchphrases were identified, which were basically important sentences that can be used verbatim in the summary. This could be identified using knowledge bases and ripple down rules, or through the citations themselves. Further, another approach would be to extract the topics using LDA and find the highest ranking sentences from each topic and add them verbatim to the summary. A graph-based summarization would make a graph using sentences or paragraphs as nodes, and these nodes were ranked using CRFs, and the important nodes were added to the summary. Finally, an innovative approach to summarization was known as paragraph extractive summarization. It was identified that there exists something known as summary paragraphs, which were basically paragraphs that had the most of the content of the documents in them. And these paragraphs would act as a summary. This was further substantiated by a study by Kumar et al. In Indian legal documents, who identified head notes as summary paragraphs. We observed that summaries would exploit the fact that legal documents may be similar with respect to only certain parts as compared to the entire document itself. While linguistic feature-based summarization methods were very effective, they
Anya, please
incurred the
conclude your
overhead.
presentation.
Yes, ma'am. They would incur overhead of building a knowledge base, whereas graph-based approaches were unfruitful. Finally, to calculate paragraph extractive summary, inter-paragraph similarity scores were needed to be calculated between every pair of paragraphs, which would be computationally expensive. As a conclusion, we have performed a novel categorization of similarity analysis of legal documents. Thank you.
Okay, Anya, I have one question.
Yes,
what research gap or research scope you find after this literature review?
Yes, ma'am. So
what is the prominent challenge?
Yes, ma'am. So we, after performing this research, we found that there was no effective way to find similarity between Indian legal documents because they were very huge in size. So we have actually performed research in which we have extracted head note paragraphs, which were very corresponding to summary paragraphs. And then we use that to find other similar documents. So that is the research that we did.
Okay, Anya, I just wanted to ask you, you just discussed one similarity measure, that is the Jacquard similarity. So
Yes,
did you come across literature where you had more similarity measures like let's say Manhattan distance or Minkowski distance or Euclidean distance being used as measures for finding similarity between documents?
Yes, ma'am. So what we, not in Indian, in the Indian legal domain, but an Australian research had used, I think, the Euclidean distance for that. But because of the size, it was not as effective. What Jacquard similarity proved is that we did not need to use the entire document, just this Jacquard similarity of the citations. No one else did that with citations.
Okay, thank you.
Thank you, ma'am.
Thank you, Anya. Now I would like to invite our next presenter, Mohammad Hassan Raza Noori.
Hello, ma'am. Can you hear me?
Yes. Hello.
Yes, ma'am.
Yes. Please start your presentation.
And can you see my slides?
Yes. Yes, it's visible.
Good evening, everyone. My name is Mohammad Hassan Razanuri. I am research scholar in Computer Science Department at JIT University, Dehradun. My paper title is Traffic Congestion Detection Computer Using Word to Vector. This is my content outline. I will discuss this content in the subsequent slides. Introduction. As we all know, traffic congestion is an inescapable condition in large and growing metropolitan areas across the world. Traffic congestion is a particular condition when vehicles are moving very slowly or stand still on the road. While commuting, people mostly share the current status of traffic around them on Twitter platform. If we talk about Twitter, Twitter is a microblogging platform that allows its users to send and receive short posts called tweets. Twitter has recently been commonly used.
Mohammed,
as a
sorry, interrupting you in between. Can you just keep the microphone a bit away from your mouth? It's the voice is cracking. We are not able to hear.
Okay, ma'am. Twitter has recently been commonly used as a source of information to track events or incidents like traffic congestion, road accidents, building collapse, riots, protests, etc. Word vector is a very popular technique for word embedding as well as for feature extraction. It retains the semantic meaning of different words in a document. The context information is not lost in the word. Machine learning is the field of study that gives computers the capability to learn without being explicitly programmed. Three main types of machine learning are supervised, unsupervised, and reinforcement learning. In this paper, in this work, I have used supervised machine learning technique. And the text mining is the mechanism for transforming unstructured text data into useful and meaningful tasks, also known as text analysis. It uses natural language processing to transform the unstructured text document into normalized structured data suitable for analysis. Now the objective. The main objective of this work is to build a traffic congestion detection system for future using word-to-vector model. While talking about GAD, in the area of supervised event detection from Twitter, word-to-vector model is not well explored by the researchers as a feature extraction. Also, our objective includes to collect the traffic congestion related fields from Twitter and label it, compare the performance of support vector machine, logistic regression, and naive based in conjunction with the word-to-vector model, and select the best one. And finally, build a near real-time traffic congestion detection system using Twitter data stream and monitor the Indian road network for the detection of traffic congestion. So this is the architecture of the proposed system. Here there are mainly four modules. First module is fetching of tweets. This fetching of tweets module will collect the continuous stream of tweets from the Twitter and pass it to the pre-processing phase, which is the second module. Pre-processing performs cleaning, tokenization, start word filtering, feature extraction, and then pass it to the third module, which is the classification module, which will classify the unlabeled tweets to identify whether it is a traffic congestion related or not traffic congestion. And finally, fourth module will display the notification of traffic congestion. Research methods include data collection. Data is collected using Twitter developer SQL credentials with a dictionary of traffic congestion related keywords. Total 30,000 tweets are manually labeled with binary notation, that is, as related to traffic congestion, labeled as traffic, and tweets which are not related to traffic congestion are marked as not non-traffic. Data pre-processing and feature extraction. First is cleaning to remove the noise. We have removed usernames, hashtags, hyperlinks, punctuation, and non-text characters. Then tokenization, it splits the sentence into individual words or tokens. Then stop word filtering, filter the most common words in the dataset like is, and, are, etc. And finally, feature restriction by using the strict grammar order of word-to-vector. And last, classification. We have used three supervised machine learning algorithms, SVM, which support vector machine, logistic regression, and naive. And models are evaluated using 10 whole cross validation process, and metrics are used accuracy, precision, recall, and F method. Its experimental setup is for classification. We have used Apache Spark 2.4.3 with Scala as a programming language, and the experiments are conducted on 64 bit into 18.0 operating system with 16 GB of memory. And for the detection of traffic congestion in real time, the Apache Spark streaming framework is used. This is the classification result. From the table, we can see that SVM outperforms the other two algorithms in all four measures. Accuracy, its accuracy is 91.73%, while accuracy of logistic regression is around 1% less than SVM, which is 95.65%, and naive based was 88.68%. From the comparison chart below, we can also infer that SVM is the best performance. Final detection of condition. So the developed system was deployed and evaluated for the near real-time tracking of the Indian road network between January to March 2020. From the table, we can see the sub correctly identified tweets by the user which shows that there is a traffic jam in this particular location. Conclusion: in the area of supervised event detection from future, what is model is not explored by the researcher as a feature extraction technique. A near real-time traffic congestion detection system from the future data stream using word-to-vector as the feature extraction technique is developed. Three classification algorithms are compared in conjunction with the word-to-vector model, namely support vector machine, logistic regression, and name-based. SVM outperforms the other two algorithms, achieving accuracy of 91.73%. And finally, the word-to-vector model SVM has been developed for real-time monitoring of Indian road networks. These are references of my paper. Thanks for the listening.
Thank you. Session chair, any comments?
Yeah, Mohammed, I have one question. Challenge you found in as long as Indian context in the traffic?
Challenges in?
You have found as long as Indian traffic context.
Most of the time, the tools coming from India is a code mixed language. Is a code mixed language. English plus Hindi is written in English. So this is the problem. So this is the problem in identifying by the machine learning. Although it is written in English, but it is not in English. And second most thing, most of the users does not turn on their GPS. So even they message, but it will not identify by our system because we have used bounding box for the entire country. So the tools coming from the GPS enabled devices are only can be used for classification.
Okay. Okay. Yeah, thank you.
Mohammed, my question is, what is the size of data set that you have used? How much of data is available on Twitter regarding Indian roads?
But actually, I have used 30,000 data. I have collected 30,000 data sets. More than it is, but I have finally decided on around 30,000 data. And from Twitter, I am not. I have didn't use the historical. I have used the data from like July to December 2019.
Sorry, I didn't get the last part. You have used data from?
Now, actually, I use the Twitter developer API credentials that they allow you to download or save or for instance purpose. We can download the suppose that I have used traffic condition related.
Yes.
Like traffic jam, traffic congestion, moving very slow, stuck in the traffic. And my data is not specific to the Indian country. My data is general.
Okay. Can you just give me one reason why did your data set perform, why SVM performed better on your data set? What was peculiarity in your data set that SVM performed better than the other two algorithms?
SVM, you know that SVM was a hyperplane and it plays better. Logistic regression and name-based are good, but they are not as much as because we can see SVM got 91 and logistic regression 90. That's why maybe this is the reason.
Okay, thank you.
Now I would like to invite our next presenter. It's Adasa Nikruma. Adasa?
Hello, can you hear me?
Yes.
Yes, good evening. I'm sorry, I will have to switch my laptop because the Microsoft Office keeps updating. So I've sent a new request. If you can accept so that I will use that laptop.
Okay, no problem, Adasa. You can start your presentation.
Okay. Thank you very much. Please, can you hear me?
Yeah, but can you please check your mic? It's a sound echo.
Hello.
Hello.
Please, can you hear me?
Yes.
Okay, thank you very much. Just a minute. Please, can the next presenter go ahead so that I be the next one?
Okay, no problem.
Yes.
Teacher, go
Yes.
ahead.
Sorry
Hello.
about that.
Yeah, I would like to invite our next presenter. It's Raghuvendra. So it's Raghavendra.
Good evening. Am I audible and my screen is visible?
Yes, please go ahead.
Yeah. Once again, good evening and thanks for the conference for giving me opportunity to present my work. So myself, Raghavendra M. Shet, along with my complete team, Dr. Nalini Iyer, Nisim Gaudar, Akash, Abhiram, Amarnath, and we are totally 17. It's a big group here. We would like to share our experience with an ongoing research work under our university. The topic which I am going to discuss today is motion control and sensor fault diagnostic system for autonomous electric vehicle. So this has got two parts, motion control and sensor fault diagnostic. The content of my presentation would be, the flow would be like this: introduction, design and methodology, then GUI, results, conclusion, and references. I just want to make a disclaimer that this is a part of the work which it's a part of a very big work which we are dealing in our university as an institutional research project. It's a completely funded project in-house, and we are building an autonomous vehicle, and a part of that work we'll be presenting here. Thank you. To start with introduction, as we all know, the future technology is of 21st century would be autonomous vehicle or self-driving car. But when we say an autonomous vehicle, it is not a new concept which has evolved, but it is as old as an automobile industry, which an Carl Benz had coined in 1886. We will be using a vehicle, a very much mechanical vehicle, but trying to induce or introduce certain human intelligence to that and to take the decision on their own for navigation. So quickly we can say that autonomous vehicle, it's capable of sensing its environment. So as a driver does. Now we are transferring our intelligence to a vehicle so that a vehicle itself will sense its environment, and it has to be guided themselves, or it has to guide itself to navigate from point A to point B, that is from source to destination. Then the autonomous vehicle or self-driving vehicle is getting progressively composite and must be proved effectively before deployment. That is a very concern of AEVs. So as we can say, 2025, McKinley Global Institute analysis also says that among 12 disruptive technologies, autonomous vehicle is one of them. And we can see that 80-20. So that 80-20 just tells that how much it can be used in a developed country and how much it can be used in a developing country. So we consider ourselves to be in the 20% wherein we are developing the technology with the economy. So this makes a very impactful sentence that coming days this technology will be evolved. So before going to the work, we have to quickly understand the autonomy levels. So these have been very much defined by the SAE and many of the autonomous vehicle building companies. So as we know, the first three levels, we start from zero and we end up into levels. So first three levels are more of human monitored. The human has to take care of the monitoring. He has to perceive the environment and he has to control. But coming to the system monitor, the flexibility of a driver is that he can keep his eyes off the road. That means the system is taking care. And coming to the higher level, the fifth level, it's a complete autonomous level, which is an ambitious, but yet the work is going on. So in Indian scenario, we can target from level 0 to level 4, max level 4, and we can easily observe that up to level 3. Yes, up to level 3, the system exists in much of the sophisticated cars. And coming to a broad classification, what can be the components of a self-driving? So a self-driving car has to map itself, perceive itself, it has to control, and it has to plan the motion planning. So if I take a very small, quick animation or quick example, this is a Tesla model. So you can see here the vehicle, the driver, he is totally dependent on the system. So what it controls, what the system is controlling is the steering and acceleration and brake. That is what the point of concern for me now in this paper. So we are working on visual aspects of that, all the sophisticated aspect, but I will be dealing only with the steering, brake and acceleration rather than steering and acceleration. So the framework what we are using in our research work, quickly I will run through this. So this is what we are using, sense, plan, act type of framework. So the input to this is usually the environment. What we have decided is a fixed path. So we are considering an optimal path without obstacle, and we are trying to run this autonomous vehicle, and the autonomous navigation would be an steered, control, accelerator control with sensor diagnostic system. So if I want to break down this autonomous vehicle, it looks to be a very complex. We are working on many of these sub modules in groups. As I had mentioned, we are more than 17 members working on this, including students and the faculty. So each one will be handling one unit. So today we'll be presenting only the one part of that, that is accelerator, brake, steering, the control module. Okay, so this is one more. This is the actual vehicle which we are working on. We have retrofitted the existing vehicle, a Tata Nano vehicle. We have first converted it from an gasoline engine to an electric vehicle, mounted all the sensors, and our team is working on majorly these 4 categories: computer vision, sensor fusion, vehicle motion, vehicle propulsion. Vehicle propulsion is an electrical vehicle. Okay, then as I had told, this contains 2 modules. There is steering and accelerator control and the sensor data diagnostic. So when I say steer and accelerator, I mean lateral control and longitudinal control. Longitudinal control are majorly controlled by an acceleration, and lateral is controlled by an steering. So that's what
Raghavendra, you have only 2 minutes. Please conclude
yes,
your
presentation. Yes, ma'am. Sure. Okay, I will just go with the, this is what I wanted to explain. Steering control is with respect to lateral and accelerator with respect to longitudinal. So this is the functional block diagram which we are using. We are using multiple sensors of heterogeneous or homogeneous way. Then we have a controller. So here we have used a local controller as Arduino, but the master controller we will be using NVIDIA Xavier boards, high computational boards. Then coming to the steering. This is an actual steering module which looks like this. The sensor which we have used is a potentiometer, whose data will be recorded with a standard path. And once the vehicle is deployed for its motion, then based on the lookup table, the actuation will be given to the steering wheel. Here we can see this is an chain-driven chain-driven actuation, but we have modified this to a gear system. That will be an update of the previous work. This work. Then coming to the acceleration, you can see here we are using a cam-based acceleration. So it depends. Since we have considered a speed of 0 to 10 kilometers per hour as our reference, we are not moving more than 10. So based on that lookup table, this cam will be rotated with a DC motor to have a desired longitudinal motion. Second part is a sensor fault. So any fault which, if it is unnoticed, it may lead to failure. So a fault can occur in any section of the system, complete system. It can occur at the actuation plant or a sensor itself. And we are concerned only with the sensor faults now. So as we had told, we are using a potentiometer as sensor, multiple potentiometers as a sensors, and we will be diagnosing it with respect to its maximum and minimum value. We are using Porter method for analyzing the fault, and we are concerned of a saturation fault only. So that is our reference. There are many types of fault, but we have taken the reference as saturation fault. This is the GUI which we have built based on the sensor health. The GUI will indicate us the diagnostic system. Okay. So coming to the results, this is the path which we have considered, an oval shaped. It's an path we have considered in our campus itself. Quickly run to the last results. So this is the GUI. Since we had all the healthy sensors, we tested it for faulty sensors also. I could not put that in the slide. So we tried to remove the wire out. Like we made a sensor to be fully saturated to 1 completely or 0 completely. Then we also mimic the speed profile, wherein the steering angle and the acceleration also is depicted, and these are recorded for the multiple rounds, and then again it is fed back to the system, which will be moving on its autonomic manner or autonomous functionality. So to conclude, we tested it on a predefined path. Then motion planning was achieved using a steering, that is lateral control was achieved by steering the control, and longitudinal through an accelerator control, and we were able to have a sensor fault diagnostic done for one class of fault, that is a saturation fault. And in the future, we are thinking of expanding this with multiple other sensors, complex sensors like global positioning and IMU sensors. So these are few of the references which we have used. And this is an ongoing work. We will be adding some more complexity to get better results. Thank you.
Thank you, Raghavendra.
Thank you.
Meenakshi ma'am and Swati ma'am, any comments?
Yeah, Raghavendra, I have one question.
Yes.
What all contextual, see, this is dynamically changing environment, right?
Yes.
So what contextual parameter you find prominently affecting on the system?
Sorry, ma'am.
What all contextual parameter
Yes,
you find affecting on your system?
Ma'am, we have considered a very standard noble condition without any artifacts or any forced faults. So the major contextual thing that we can find here with respect to is the algorithm, predefined algorithm which we have used. So that is one major challenge for us. Like we had tested for an obstacle-free track, but if we have an obstacle, so the behavior of the design system completely changes. So I can say that this system may not work for that application. So I have to rework on the other sensors. I have to be dependent on the other visual sensors also.
Okay. Thank you.
Thank you, ma'am.
Hi, Raghavendra. My just query is that could you call your system as an IoT system, because it's all about collecting data from sensors and actually driving the autonomous vehicle on the basis of that?
Ma'am, I would not say it as an IoT because I'm not communicating it to the third system, but I will be using the sensor data in my system itself with the local controller. So I will be having a master controller to perform all the complex systems like obstacle detection, navigation, and localization. That's a very big chunk of an autonomous vehicle using a LiDAR sensor. So from a master system, I'm going to take something for the local controller to do its work. That local controller will be sensing only that fixed 4 to 5 sensors connected to it. So I would rather say it as a local control.
So how are you taking care of, let's say if it's an autonomous vehicle, it should be at least able to cater for the kind of traffic conditions that you can expect in an ideal city.
Definitely.
So and you said that the speed limit that your vehicle is currently you are just driving it at 10
Yes,
kilometers per hour.
Yes.
So how much is it actually a usable thing? That's what my query is, that like you are running it on a very isolated kind of an environment where you know what parameters to control and how. So have you done any kind of a test or any kind of a simulation on a real road scenario? Let's say even if it's moving at 10 kilometers per hour, how good the vehicle is on the roads? Have you done some kind of a simulation like that?
Yes, madam. Yes, madam. We have done. We are for that system. What you're talking, we are dependent on much more complex sensors like a camera, a depth camera, Intel RealSense depth camera, and a lidar. So for we will be moving from this system to that system. We will be depending on that. And coming back, the usability of this is only to assist a driver for his maneuvering. I can't totally depend on this system for an auto vehicle manual. So it's an like if we go through some governmental regulations, so even a testing of an autonomous vehicle in Indian road scenarios is not
Is not
permitted.
permitted. Yeah,
Yes,
that's
madam, that is a very big hitch here. So that's why we said like we are into that 20% of developing. So and for a real time data for a real time Indian scenario, it will be a very challenging task. At that time, we have to be dependent on the higher order controllers. Like we should be dependent on cameras and lidars.
Thank you so much.
Yeah,
Thank you.
thank you, madam.
Now I would like to invite our next presenter. It's Prabha.
Hello.
Hello.
Hello. Yeah, good evening, all of you. Am I audible?
Yes, Prabha, you are audible. Please start your presentation.
Okay, my slides are visible.
No.
Okay, one second.
Prabha, is there any problem in slides sharing?
Now the slides are visible.
No.
Prabha, if you are facing any issue,
Yeah. Just one second. I leave the meeting and then again join. Shall I try like that?
no issue. You can just leave the thing. Go ahead with the next presentation. Otherwise, consider the ADASA for the presentation.
Yeah, yeah. Okay. I'll just leave and join again.
No issue, Prabha. Dicha, go ahead with the next.
So I would like to invite our next presenter. It's Adasa. Adasa, please start your presentation.
Please, can you hear me?
Yes.
Can you see my screen?
Yes.
Oh, thank you very much. I'm sorry for the previous mishap. My laptop started updating. I needed to switch. Sorry about that.
It's okay, no
So,
problem. Please start your presentation.
yes, I'm going to talk about the concept of the Ghanaian government, social media, and access to information. And my name is Adasan Nkrumah Kofi, and I'm the main and the corresponding author. And currently, I'm in the University of Electronic Science and Technology of China, Chengdu to be precise, but I'm originally from Ghana in West Africa. And these are the other authors. And these are my outline for the presentation. Now, just to give you a background of my study, when it comes to social media and politics.
Sorry to interrupt you, Adasa. Your slides are not moving.
Whoa. You see?
Yet not.
Can you?
No, we are only visible to
No?
slide welcome.
Can you see?
Probably you need to do slideshow for just press the slideshow from current slide, and then probably we can see your slides.
Yes, I've exited slideshow, but now I'm just the connection is not supporting the animation, so I've just exited the slideshow. Can you see?
No, Adasa.
Adasa, you can just play the slideshow. The right hand side you tap.
I know, but can
Yes.
you see my screen?
Yes. Now you can go ahead. Next.
Okay. So, can you see?
No, the screen
Please, can you
share is
see?
off.
All right, so I would just have to exit the screen and do normal presentation. So this is my outline for the presentation. To give you a background of my study,
Adasa, we
please,
are
can
not
you
able to
see
see
this
your
slide?
screen.
We have the, oh.
Just hold down. Yes, now you can go ahead.
All right, so when it comes to social media and politics, it started in the US with Dean Howard, which was replicated by John Kerry, and Barack Obama is credited to be the politician to have successfully used social media in politics. The resultant effect was the phenomenal use of politics worldwide. We can talk about in the Arab Spring in Nigeria, Goodluck Jonathan is credited to have launched his campaign on social media, and that can be said of so many other examples. Now, when it comes to the Ghanaian contest, the same situation appears. In the 2016, the previous election of Ghana, we had widespread use of social media, both the incumbent and the opposition party. So when we look at this, and most of the studies are concentrated in the Asian, in the European, North American, and the South American context. And this increases the importance of our present study. Now here, the study focuses on the state of art on social media governance with regards to information access in Ghana. And here, the focus is on the government social media use context based on documental and social media analysis. So we talk about the use of Twitter as our main analytical effect to find out how the government leverages the power of Twitter as an important information platform for participatory democracy. So this is the focus of my study. We want to look at the extent of political social use in the Ghanaian context. It helps to distribute information on the ordinary citizen in Ghana. We highlight the interplay of government, media, citizens on social media, and how that contributes to sustainable government. Just to skip and go on, I just want to give you an idea of the Ghanaian media. And this is the statistics currently. There are about 128 certified TV stations in Ghana compared to, we have more radio stations, of which 505 are authorized and about 400 are in full use. We have newspaper readership to about 15 million audience, but now, the intention of this slide, when the details is on the main paper, we can see that even though we have widespread media in Ghana, all of them are moving to social media, okay? The government discussion is so prevalent on social media. So we want to look at the extent of this with regards to access in the Ghanaian context. And why do we have to look at that? We have a lot of treaties, a lot of charters in the African, in the United Nations, in the Ghanaian constitutions that talks about the need to access information by the government. And just to skip, our analysis shows that ideally, all the government social media accounts in Ghana are openly accessible. They are downloadable in different formats. The main information hub of the Ghana Statistical Services is also very active with so much information, which is easily accessible by anyone. One can easily make formal requests either online or offline. And the Ghanaian government uses different social media platforms to engage citizens. And here, our focus here is to compare how social media usage is in Ghana compared to other jurisdictions. So as an example, with this slide, we look at the Ghanaian government. The first two bars are the main opposition leaders in Ghana. From our analysis, we compare these from the office of the president, the engagement on Twitter. We compare it to other OECD countries like Estonia, the Finland government, that of Malta, in Israel, in South Korea, in Japan, and in Turkey. And we can see that ideally, yes, the Ghana government is doing so well. I mean, in terms of the political leadership, in terms of the office of president. Next on my slide here also, our analysis from Twitter talks about the engagement between the two main political leaders in Ghana, and that is quite phenomenal as compared to other jurisdictions. And this one also gives more details about what goes on Twitter with regards to the Ghanaian government and other jurisdictions. Now here, what is the extent of social media use? Our analysis show that the government leverages on the power of Twitter as an important information tool for participatory governance in different formats, being it video, text, animations, audio, and graphics. There are easy to use buttons. The Ghanaian government uses Twitter to disseminate different forms of information with regards to laws, policies, projects, and so on and on and on. And indeed, the activities of the Ghana Information Service through the Ministry of Emphasis to the online practices. And here, just to skip for the sake of time, we analyzed the extent of engagement by comparing it to other jurisdictions like somebody like Donald Trump in the USA, Cyril Ramaphosa in the South Africa, with the president of Ethiopia, and among others, to look at the extent of engagement. And we can see that indeed, yes, it is quite good in Ghana. And this also talks about, we used network structure analysis as a measure of centrality. So here we find out the degree of the connections and the measure of the extent of how popular the information sharing from the Ghanaian government is to elsewhere in the rest of the region. We situate the extent of the relationship between the leaders by analyzing the links that enter and leave their various accounts. And we can see here, when we consider the degree in and the degree out, the betweenness and the closeness as comparison to elsewhere with Paul Kagame, Donald Trump, and others, we can see that yes, indeed, the extent of engagement is quite phenomenal. And over here, it's also quite similar. Now, an important aspect to answer one of the questions as to how social media leads to sustainable government. We have detailed several examples in the main paper, but just to give you a gist. Now, as a result of our analysis that we have done, an example here is how it has helped to achieve the concept we call we government. So here, there's been improved communication and collaboration, public participation in governmental decision-making. So our analysis shows that there's been improvement in decision-making. And here, an example is an engagement on social media. An engagement on social media that asks this question: in your opinion, over the past year, has the level of corruption in the country increased, decreased, or stayed the same? This is an example of a social media engagement. And here, this corruption, perception of corruption is, and we can see from the populace what is going on there. And this here, our analysis. Now, the key points we want to talk about here is the fact that ideally, information access on social media has led to reduction in what we call, what is called information asymmetries, where one part has more information at the disadvantage of the other. And this has helped to address the principal agent problem inherent in most government. And here, the government is able to monitor the pattern of citizens' behavior, and it has given opportunities of citizens to participate in policy refinement to improve the result of the widespread information sharing on social media. And just to conclude, we have presented here the extent of political social media use in the Ghanaian context and the involvement of social media in information distribution. We talked about the extent of political social media use and how the Ghanaian politician is as compared to elsewhere. And our conclusion is that indeed the government leverages the power of Twitter to increase people's awareness and engagement in democracy. And the key point is that even though social media may not be an enormous social economic, may not have enormous economic value creation, developing countries like Ghana with limited financial resources can make good use of the platform for sustainable governance. Thank you very much.
Thank you, Adasa. Meenakshi ma'am and Swati ma'am, any comments?
Yeah, Dasa, I just had a small query. For all your results that you've shown, the degree in of all the people that you showed is 0. Can you justify what's the reason for that? The degree in is always 0, no matter whichever political figure you've considered.
Yes, for instance, the degree in here mostly is 0. The inference is that they send out more information than they receive. And perhaps, politicians are always busy. They like sharing, like we can talk about Donald Trump as an example. Every day he is tweeting. But when it comes to maybe those coming into his Twitter is usually 0. So our inference is that they sent more out than they actually receive. And I think that most of them are quite busy in their political activities. Thank you.
Okay. Also, what is the source of your data that you have taken? Like, have you done web scraping, or where have you obtained this data from that you have used in your study?
Exactly. Thank you very much. We took the data from Twitter from the year 2015 to 2019. So this is exactly Twitter data, the extent of engagement on Twitter. So the data set actually comes from Twitter.
Okay. Thank you so much.
When we look at here, this is the engagement from June 2015 to March 2019. Thank you very much for having me.
Thank you so much. Thank you.
Now I would like to invite our next presenter. It's Prabha.
Hello.
Hello.
Yeah, I will try to share my screen again. Just okay. My screen is visible.
Yes.
Yeah. Okay. Good evening, all of you. My presentation is on virtual simulation and testing platform for self-driving cars. So this presentation is a continuation of the previous presentation that was done by Raghavendra Sheth. So this is again a part of our institutional research project, which is on autonomous electric vehicle. So some one of the small component Raghavendra has presented. Similarly, I am also presenting another small component of our institutional research project. So as the title says, it is about virtual simulation. So it is nothing to do with the hardware. So in the previous presentation, Raghavendra has shown like some, we are working on some car and realizing our autonomous algorithms on that car. But before putting the algorithms on that real car, so how the virtual simulation happens, how in the simulation environment we provide different test conditions. So that is, this presentation is about mainly that kind of work that is about virtual simulation and testing platform, so which we are using it for self-driving cars. So the contents of my presentation is like this, like introduction. First, I'll just try to tell you what is the relevance of virtual simulation. So then objectives of work specific to virtual simulation. So what is that methodology we have adopted, how it has been implemented, and what are the results. And for testing these things, some different test conditions we have generated, I'll be discussing about that. And finally, I will conclude my work. So as introduced by even Raghavendra, the introduction is like this, like the virtual simulation, whatever we are doing, it is for the self-driving cars. So self-driving cars, as we all know, it is also called as autonomous vehicle, autonomous connected vehicle, driverless car, robotic car. It is that kind of car which is able to sense the environment and navigate by itself, move safely with little or no human input. So this is going to be our, this is the larger level. It's a project, main project. As a part of this project, for this we are trying to provide the virtual simulation part. So the main functionalities before before understanding like how to provide virtual simulation. So what are at the very broader level, what are the main functions that autonomous car provides? So what is autonomous functionality? So that is like, when we look into that, it's about mainly sensing the surrounding. So gather the data from the surrounding. So from that sensor, that information, the vehicle is going to perceive or when environment perception it is going to do. So that happens in terms of localization or interpreting the sensor data. So then once the interpretation is done, so then according to the interpretation or the perception, the planning has to be done. So decide on what to do, that is going to be the next stage. And then the action part, the control part, deciding on the trajectory, so that has to be done. So this is at the very top level. So what autonomous car has to do, it's basically about sensing, perception, planning, and control. So for this cycle, wherever possible, we are trying to provide the simulation environment, because so directly the algorithms cannot be tested on a real road. So before testing our algorithms on the real vehicle, so how in a simulation environment, so those can be tested, and how different test conditions can be generated. So the work is about that. So virtual simulation platform or virtual simulation program, it's about the program which allows the user to observe and operation through the simulation, so without actually using the hardware. So why we need this? Because the hardware, before deploying the algorithms on the hardware platform, so the algorithm has to be tested for all the possible test conditions. So for that purpose, we need the virtual simulation platform first. So first test the algorithm on a simulation environment. So once the algorithm is okay, and it works good for all the different test conditions, so then these algorithms can be, along with the real sensors, these algorithms can be deployed onto the hardware. So in line with this, so the objectives are going to be like this. So to realize virtual simulation, what we have supposed to do is to maneuver the vehicle in an identified path. So as earlier told by Raghavendra, so this project we are doing it at our college campus. So along with multiple departments, some multiple students and faculty involved, and also like industries, even Robert Bosch is also part of this project. So like what we have decided is initially to test our algorithms or the car, whatever the autonomous car, whatever we are trying to build. So it has to be like navigated in a campus, the college campus. So first we have to identify the trajectory. So in line with that, the virtual simulation is being done, and in line with that, the objectives are framed like this. So to maneuver a vehicle for an identified trajectory through a vector map and plan the motion along the virtual platform. And once it is done, the map has to be understood to perceive and analyze the map environment. And the next objective is to train and give the learning to the car the car has to be made to move in a identified path for multiple times for multiple conditions, so that it can be trained and the car can learn, and to navigate the autonomously in a predefined path, and also for different test conditions this algorithm should be working. So these are the main objectives of the virtual simulation platform. So to realize that, we have used the AutoWare simulation platform, so which is going to be which is used as a part of ROS robotic operating system. As a part of ROS, we are using AutoWare simulation platform. So for this, like what we are doing is the whatever path has been identified. So that path for that path, the data has been collected. So that the path, the entire the trajectory of the autonomous vehicle is generated, and those trajectories have to be like mapped in the form of vector map, so that the localization is further done. And also, like, there is in the simulation environment, so where we are using AutoWare, there is option for adding the camera data and the lidar data. And along with that, so when we're adding camera and lidar, the trajectories would be trajectories is like traced properly. And also the camera is going to help us along with the localization, it is also going to help us in identifying the obstacles, to detect the surrounding objects, and also to test the edge case scenarios on a simulation platform. So these are like few things what we are doing using the simulation platform. So the implementation is being done using the AutoWare. So AutoWare, like in AutoWare, what we are doing is like all the data, whatever through sensor it has been collected, it has been fed in the form of a ROS bag. So from the ROS bag, the point cloud data has been used, and the map has been, vector map has been is generated. And along for this vector map, we're going to combine the camera and the lidar data. And so along with that, objects and obstacles would be detected. And so again, further the test for the different test conditions would be generated to test our algorithm. So this is at the first level, like when the college map is created. So the data is in the form of point cloud data. So that point cloud data, when it is converted to vector map, so in the AutoWare environment, so the second figure shows the vector map with a street pole and edges. So this is the PCD file is the point cloud data of our college data. So when we the data is collected using the lidar, when it is the car is moved in a college campus. So from that data, from that point cloud data, the vector map has been generated. So then, so this for this vector map, it has to be like the first part of autonomous vehicle realization is the environment perception or the localization. As a part of environment perception, we have to do the localization. So localization in the sense that making understand the vehicle where it is. It is location has to be identified. So from the vector map, the next step is going to be the transforming that map into the proper raw yaw, pitch, roll data and XYZ coordinates. So that is being done using NDT algorithms, normal distribution transforms. So once it is done, so the from the point cloud data, vector map is generated. From the vector map, we are able to generate the we are able to understand the where the vehicle is. The localization is performed.
Prabha, you have last 2 minutes. Please conclude your presentation.
So this is the like result of like after the NDT mapping, the localization results. Like the data is in terms of the localization in terms of yaw, pitch, roll, and the XYZ coordinates that can be seen here. So so once it is done, so now the data has been the car. Where is the car? That part has been understood, and perception has been done. Localization has been done. So now on the way of the vehicle, if there are any objects or obstacles on its way, so they have to be detected. So same in AutoWare environment, we are realizing some object detection algorithms are implemented and the obstacles are detected. So then once the obstacles are detected, so next state is like next thing is like we have to identify different we have to generate different test conditions. So those test conditions were generated using SLV simulator. So the different test conditions like here, this is the image showing like different test conditions are generated in a simulated environment for GPS, IMU, lidar, camera. So for different conditions, so different test conditions are generated. And so these test conditions may be for like generating the night mode scenario, creating the pedestrians, traffic light, so weather conditions. So all such kind of test conditions are generated, and how the algorithms are going to behave for such conditions. So that would be tested. Uh, so uh, so like mainly I would like to conclude saying that the work whatever I have presented is part of the autonomous vehicle project. So wherein it is going to be only about the simulation part, so virtual simulation without using any real hardware or real sensors. Only the data collected is maybe data available in the freely available data that can be used, or like in our case we generated the data for our college campus, and that data is how we try to navigate our vehicle in that trajectory whatever we have identified, and we generated different test conditions and our algorithms how they are going to behave for such different test conditions. So we have verified. So this is one part of autonomous electric vehicle project. So some different references like basically on a virtual simulation platform we referred. Yeah, so this is this work is like a continuation of like previously what Raghavendra has presented. Yeah.
Okay, thank you, Prabha. Meenakshi ma'am, Swati ma'am, any comments?
Yeah, Prabha, I have one question. Thank you for the presentation. I want to ask, like, what all faults you have generated in the simulation, especially?
What all faults?
Yeah.
Like fault in the sense like for different test conditions, like if when the obstacle comes, how the vehicle is going to take a turn, steering conditions, so speed profile, speed variations, so different road profile conditions like level road, slant road, so that kind of conditions, different speeds. So like some basic minimum test conditions like we have started with. So this is going to be the big project. So just we have recently started with this project. So we are working on part by part. Yeah. Hello. Yes.
Yeah, Prabha, what I can make out is that the project basically has a lot of object detection to be done, but I could not see any algorithm that you have discussed here. So which specific algorithm are you using for object detection as far as your simulator is concerned?
Yes. Obviously, if it is object detection, we are going to use YOLO. That is the YOLO V3. That algorithm we have implemented in AutoWare environment.
Okay.
So all such algorithms we are implementing it in a AutoWare environment. So that is what is our like main focus. We are using multiple algorithms. So those algorithms have to be tested for our condition. So like for example, for object detection, we have used YOLO V3.
Okay. Yeah. Thank you. Because that was kind of missing in your presentation. What algorithms are you using for detection? Thank you.
Yes.
Yeah, there is one co-author of this paper. He might be sharing something.
Yeah, like you, Ajit.
Yeah, I wanted to tell that ma'am has asked like what all the algorithms you are using. I wanted to answer for that question. Like ma'am, we are currently using the LGSL simulator for testing different type of situations, creating different type of environmental, and how the vehicle will react for that. For creating rain, creating rain environmental, we have developed Python APIs for that. And we'll test that how the autonomous vehicle will react for that. And other thing is like for that other thing is like how the pedestrian will we'll create the pedestrian in front of that autonomous vehicle, how the autonomous vehicle will react. We have tested for all those cases and all. Like in AutoWare only we can modify those real time. We haven't taken any data set which we got from the online. This is our own college data set, and we can modify those data sets according to our requirements, and we can test that autonomous vehicle how it will react. This is how we implemented this virtual simulation platform.
Okay, thank you so much. Thank you.
Yeah.
Thank you, Ajit. So as we completed all the presentation, and once again, I thank you to all our presenters and our session chairs. And now I would like to invite Dr. Amit Joshi for a closing remark.
Good evening to everyone, and if there are any international presenters, good morning and good afternoon. I hope everything is went well, and we are in new digital times. Conference sessions also have moved to digital, and I am pretty sure that it is very much difficult to handle a digital session rather than a physical session, because you need to get stick to screen for a longer number of time, and you cannot reflect back through that, and then patiently listening the presenters and then commenting on their work, questions and answers. So it's a really tedious job, and I thank both of our chairs, Dr. Swati, Dr. Meenakshi Arya and Dr. Swati Nikam. Thank you for sparing your valuable time, and we hope to see your efforts goes fruitful and authors may get benefited from your comments for their future research work. Thank you very much, and I would request Richa to share the token of remembrance to our session chairs, Dr. Meenakshi Arya and Dr. Swati Nikam. These are certificates from which will be shared to you on mail, Dr. Swati Nikam and Dr. Meenakshi Arya. Thank you very much once again for your support in organizing this technical session. And for the presenters, I have two informations. That one is that you will also receive your payment certificate, payment receipt, your certificate and your thank you letter just after the session on the emails. If you have any concern, if you have any issues, just let our conference team know, or you can also mail it to me at amit@gr.foundation. Secondly, regarding publications, we have already sent the data this time to Springer before the conference itself. So everything is in place, and the Springer has started working on it, and we hope to complete the publication process this time nearly early in about 3 to 4 months. I hopefully, but it is only in normal circumstances. It can delay up to 5 months. I'm not sure, but we will try this time to get it as soon as it is published. And I wish you all the best for your future endeavors, and hope that you also attend the technical sessions of this conference tomorrow. I think tomorrow also there are 9 sessions, Richa, scheduled. That is 4 ABC, 5 ABC and 6 ABC. So we will have discussions, we will have talks tomorrow also. Until that time, thank you very much, and especially to the both chairs, Dr. Meenakshi Arya and Dr. Swati Nikam. Thank you very much.
Thank you so much. Thanks.
Thanks.
Thank you, sir. Thank you so much.
I think within a minute, Richa, you can close up this. If anybody wants to interact anything on messaging chat, they can do it right now, and after 1 minute, you can close this channel. Thank you.
Thank you very much.